So in this case, we are going to consider as a continuation working on our line shafts. We managed to have the basics of the line shafts and some of the calculations that we had, and also the application of the moments where we are to calculate reactions, which can be vertical or horizontal reactions. So if you consider, or if you're to check from the previous class that we had, because here we're going to consider the bearings and that part being the support, where you are to consider other forces now or the weights that you are given. But as we had the pulley system, before we move on to the application now of the gears, because we want to consider the effect when the gears are part of the system. Previously, we had the pulley, which is just considering the pulley system and a condition of a flywheel, which we just consider the weight. Like I said before, you consider only the weight when you're dealing with what? A flywheel. So on the pulleys, I didn't go much into detail because if you consider what happens on a pulley system, it is one thing to be done throughout. If we are dealing with vertical components, let me just put a summary. Let's say we are dealing with vertical components where we are to consider vertical reactions in our case. Finding or calculating of R1 and R2. If you are given the pulley system where vertical reactions are to be determined, you can consider the weight when it is given. When you are given the weight of the pulley, it will be considered as part of your calculations. And the weight is taken vertically down. It will be going downwards. So as it will be going downwards, that's a negative pointing down. The weight will be pointing down. So this is what I'm trying to say. Remember, you'll be having your bearings as your supports, another one. So the weight of the pulley will be taken that way. So this is what you'll be having. All right. So this will be the weight. Then you can apply your moments. If you are given the weight, you must consider it as a vertical component. So it is used for what? Vertical reactions. Then also on a pulley, mostly you'll be given tensions instead of being given the weight, they will give you the tensions. You are given T1 and T2, whether it is going down or it is going up. So if you check in our previous presentation, I didn't explain much about these to say what will be the effect. The reason being, all right, let's consider this to say, let's say you consider the pulley. I told you that the pulley system, what it does in terms of the tensions, they oppose our bearings. So what if it is going up as of the tensions, like here it is vertically going up, it means our bearings will be experiencing a downward force. They'll experience a downward force, the bearings. So if our bearings now are part of the support, this is what you are given. This is your bearing, all right? So we're going to have something like this. You're considering a pulley system, but it has what? Tensions vertically up. They are going up. So in your presentation, you were supposed to have it this way. You were supposed not to say this is what you're going to do, but you can do it if you understand it. It's not a problem. You were supposed to have it like this, where the tensions are facing up. So you can actually use this concept: up, positive, when you're going up, negative, down, to the right, positive, negative, like that. So in our case, we are dealing with what? A vertical, positive, like this. So it'll be facing up. So what happens now with the pulley system? The bearings will be experiencing an opposite force to what you're given here. So if it is going up, always of our tensions, it means our bearings will be experiencing a downward force like this. Our bearings will be experiencing a downward. So now, because of you guys working with these bearings facing down and this one is facing up, most of you end up having confusion. So we tend now to ignore that and use in a normal consideration that you are used to, where you just have to switch, all right? The way that you are given these arrows facing down, you just have to switch them, and you also switch this one. So at the end of the day, you are going to see that this will be just identical to something like this, all right? It will be identical to something of this nature. You switch, so this is going to face up, this is going to face up. This is what you are used to as your supports. So this is going to switch. Then it faces what? It faces down at the end. But previously, the original diagram, it was supposed to actually look like this. So if you can apply it this way, no, not a problem. Use it. Use it. So I avoided this consideration because it will tend now to confuse us. Now, this one we are putting this way, the other one we are putting this way, because especially when you check now your exam preparation or your exam question papers, you see that they will be just putting your diagrams like this. Then you'll be like, but I'm used to this. Then the diagram is like this at the end. So whenever you have a pulley, it is the tensions going up where the bearings were supposed to be experiencing a downward force in this manner. You just have to switch your diagram, all right? You just take them the way that you are used to, where you have got these supports facing up, right? You are used to that. Then you can do your calculations. But just know that on your answers that the reactions will be experiencing a downward force as originally what we had here. It is just for a calculation purpose, that to use something that you are used to. So if we're to consider the second part where these tensions are facing down vertically, they are facing down negative like that. So it means we were supposed to have something like this, all right? We're supposed to have something like this for our pulley. We have got our bearings. But what is happening? Remember, the pulley, the tensions will oppose what is happening to our bearings. So means that these ones, as they are going down, we are going to have the total of it facing down. This is the total of these two tensions, all right? This is the total of these two tensions. So we have this total here facing down, meaning to say what is happening with our bearings, they are experiencing an upward force opposite to this one. They are experiencing what? An upward force. And being upward as it is, this is, guys, what we are used to. So there is no need for you to change your diagram. Upward is just like that. So there's no need for you to change it because already these are your supports and they are facing up. Here we are to interchange because we are seeing that our supports now will be facing down. All right. These arrows will be facing down, which is not a problem. You can use it as it is. It's not a problem. It's only that you get your answers being negative. The other one, you're going to get your answers being positive, which is not a problem. So if you are used to this, then maintain that. But this is what you can actually use, especially for exam purpose, so that you just follow what you're given. So at the end, in summary, you can see that for a pulley system, working or calculating vertical reactions of the bearings, this effect of going up or down does not affect our diagram at the end, because even if it was going up, we had to interchange this, we had to switch. It is now going down, where these ones are now going up. So this is the same as this one, no effect at all. No effect at all. If it is going down, if these tensions are facing down, then these are the ones that we have, they're facing down. What is happening on the bearings opposes, they'll be facing up. So there is no need for you to change there. It is exactly what you are used to. It is just like you are given, what can I say, a mathematical question which cannot be simplified further. This is the condition that we have here. This is the simplest format that we are used to in terms of the diagram. So there's no need for you to change it. Here we are to change to the simplest format that we are used to. So whether facing up, facing down, the diagram at the end is the same. This type of a presentation, it is just like in our mathematics where we deal with angle of elevation and angle of depression. The calculations, the diagrams, the other one will be telling you the diagram is like this. The other one will be changing now the diagram. But at the end, you'll be ending up with a right angle, the triangle to solve those. It is the same thing with what is happening here. The statement given can be originally, yes, presented like this. But because you know of what you're dealing with, put your diagram the way that you are used to. Then you can calculate. That's for a pulley. We are going to notice something when we are dealing with the bearings. There, you must be very careful. That's why you saw I did not even explain much. But for those who be wondering, wow, how is this one like this? This is the reason. This is the reason. So all presentations of a pulley system must be in this form so that we can be together. All right. So let's consider horizontal. All right. So as for horizontal reactions, horizontal reactions. All right. As for the horizontal reactions, this is what is going to happen for the horizontal reactions. As you consider the pulley system, you be either having these, maybe they are facing the left side, so these are your tensions, or maybe facing the right side as your tensions. What is happening, guys, is that, all right, you know that to the right it's positive, to the left it's negative, you know that. So in our case, as the tensions are taken to the right, it means the bearings will be opposing. Is our tensions taken to the right? From what? From the pull. It means what is happening on our bearings, the bearings will be experiencing leftward force. That is the condition. So if you were to present now to say, all right, I want to present this, we have our bearings here. All right, let's start with the one that has negative tensions, the tensions here that are on the negative side. They are facing negative. So meaning to say negative, that's going down. So it was going to be like this in terms of the tensions. You add them T1 and what? T2 combined together here. Negative. Remember always about the pulley and the bearings oppose. So meaning to say as they are facing to the left, the bearings will be experiencing a rightward force, meaning to say positive. A rightward force, meaning to say positive. So this will be our bearings facing up, positive. This is what you are used to. So there's no need for you to change your diagram. You are used to this, your bearings as the support facing up and any other load like that. You are used to that. So you can maintain it, calculate whatever that you give the reactions. But when it is like this to the positive, you're going to say, all right, since it is to the positive, then it means facing up. So these tensions were going to be like this. You're going to have something like this. Combined together, these tensions, they are what? Positive going up. These are the combined tensions. So what happens now with the bearing? It opposite to the tensions, meaning to say it will be, since this is going to the right, so we'll be going to the left, which is a negative. So a negative, meaning to say on our diagram, you present going down to say it's a negative, all right? But look, guys, this presentation that we have, it is similar to the presentation that we had before when we were dealing with the reactions for the vertical, when we were taking this one going up, then we had to change. So at the end, when you have this, what were you going to do? You're going to change it. Now it is in that manner, because this is just simply identical to this, as it is what? As it is going, as these two are going down, this is up. So you just simply oppose. So at the end of the day, you are going to see that whether you are to the right, you are to the left, as long you are dealing with a pulley system, the diagram at the end will be simply this way. Only that understand to say they are taken to the right, the tensions. So therefore, the bearings are experiencing leftward force. The tensions are taken to the left, therefore the bearings are experiencing what? A rightward force opposite to what you're given in terms of what? Those tensions. But the diagram, simply the same. So that's why you see all the questions that I had when I was dealing with the pulley system. I was just using same diagram like this for all. Because of what? If it is like this, you can change it. Look, just swap it to that manner, to what you are used to. So at the end, you see that all can be presented in the same manner. Horizontal reactions, you present your diagram like this, you calculate your reactions. This is the idea. Vertical reactions, whether you are given this condition, at the end, your diagram will be like this. So you calculate your what? You calculate your reactions from there. So that is what you have. So meaning to say, for exam purpose, don't stress yourself that much. Whether you present it this way, it's not a problem. So you can use what you are used to. But as we are going to have questions also later on, working with exam questions, you understand this idea of answering these questions to say there is no effect when working with what? A pulley system. At the end of the day, the diagram that you're going to have will be the same, whether it is horizontal or what, or vertical. So this is what we are simply going to have. All right. So for these vertical reactions, whether going down, going up, our final diagram will be simply like this. You'll be having your bearings. So where there's a weight, you also consider that weight. All right. If you have got the weight, so you must also consider that weight. So this is the sum of T1 and T2 with the ones that are vertically given, whether going up or going down. All right, then these will be your reactions to the bearings, bearing 1 and what? And bearing 2. So that's R1 and this is R2, just like that. So if the weight is given for a vertical, you can also consider that weight. You must also put the weight on the calculations. So meaning to say, it will be involved, the weight will be part of your calculations. But you must also consider when, let's say, your tensions are going up, all right? The weight is going down. These two, they're opposing. So meaning to say, you must subtract. You must add when they are facing the same direction. So that is what you are going to have. Then for the horizontal again, whether we are to the left or to the right, we are still going to have our diagram in this manner. This is what you're simply going to have, all right, where this is the sum of those tensions T1 and T2 in the horizontal. These ones are for the horizontal, T1 plus T2 of what? Of the horizontal. All right. Then this is what? T1 plus T2 of what? The vertical. Anything that you have there on the vertical, you take it as a consideration to say it must be considered. So what you can do is to have a sketch of how the original diagram was supposed to look like. Then you transfer it to this format that you are used to, which is the easiest way that you can work with. Or from that original diagram, you can still maintain it. Only that in some calculations, that's when you get negative values. It is because of the direction that you are choosing. It's not an effect. You can maintain that. So this is for you guys. Horizontal reactions, one diagram. All right. Vertical reactions, one diagram for a Pulley system. Only that the reactions will be in opposite direction to what the pulley, to what the tensions are. If they are up, they will be experiencing a downward. If they are down, they will be experiencing an upward, opposite to what the tensions are presented. So in our case, we need to consider continuation working with the gears, because the gears, they have their own application different to what we had when we were working with what the pulley system. The gears, they have their own, so you need to understand what you have when working with a gear system. As we do understand that a gear, it is just like a pulley that is being used before. It is a transmission element used on the line shaft. So just like what we had on the pulley system, from the pulley system, this is the same idea that you're going to have when you're dealing with what? With gears in the transmission as a transmission element. So what you need to work on is actually the basics of the gears from your N4. Remember, you dealt with the gear, which is the types of gears working with the simple, the compound, the planetary gears, their presentation. So if we have got meshing gears, which is the major part of our calculations that you're going to have, if two gears are meshing like what we are given, say this is the first one and the second one, interlocking like what we are given there, we are going to consider that two or more gears are engaged. So in our case, we've got two gears that are engaged, that they are meshing. In this case, you have what you call the line of action according to the rotation that you're going to be having. There is the line of action and the baseline. In between, we have the pressure angle. In between, we've got our pressure angle, which is approximately 20 degrees. So in a case that you are not given, this one will be taken at what? At 20 degrees, the pressure angle. All right. So given the line of action, which is going to affect in terms of the presentation of how the gears are in terms of the rotation. Let's say we have got this condition, the driver and the driven. So we have got a rotation that is happening to say we can have this one in the what? In the anti-clockwise rotation like this. So what actually happens is you are going to have your Ft, which is the tangential force, affected from the direction that you're given. So if you maintain that direction the way that it is telling you that your tangential force will be this way. This is for n what? Anti-clockwise. If let's say it was in the what? In the clockwise, like this, it is going clockwise. So it means our line of action will be affected the other way in our clockwise direction, to be affected other way. So meaning to say we'll be having this way to the left. And anti-clockwise, you will be having this to the right. So these will affect mostly when you are doing the calculations later on. That's when you're going to have the effect. But for now, you just need to know is the gear system, and those effects, we're going to see them because of the forces that are affected. Like when you are given the two gears meshing like this, there are forces which results in what? In these two gears. We are going to have, we are going to actually list the types of forces, then also the calculations, which is important. All right, let me just list these forces before we look into the calculations. That's an important aspect, actually. Let's consider the forces to consider when gears mesh. So we are going to see that when the two gears mesh, three forces are to be produced. Three forces are to be produced, which is the tangential force. All right. We also, this one is applied along the line, which is the tangent to the point where the pitch center diameters of the two gears meet the line tangent. So mostly taken as a horizontal, but also it is on the presentation of the diagram. We cannot say that's a conclusion to say it's going to be taken as a horizontal, all right? It depends with how the diagrams are drawn, especially for your calculations. We also have the radial force, which is another aspect they're going to actually ask you there, which starts from the center of the gear and directs outward towards the what? The pitch center diameter, which is the main aspect of the radial force. And also we have got the normal force. So actually when you're to have this, yeah, mostly in terms of your questions, they'll just want you to list these, all right? Just the basics of forces. You can be asked to list them, all right? And like I said, the radial force, tangential force, mostly these are affected on how the diagram is actually given. But in a basic view of a normal gears in a mesh, we are supposed to have a right angled triangle when these forces are connected together. They form a right angled triangle. And in between the two forces, which is the normal force and the tangential force, is where we have got the pressure angle in between. So this angle is our pressure angle. So that's our Fn. This is our Ft, and this is our Fr. So that's a normal presentation. Your Fr can be going up, can be going down. All right. Your Ft can be to the right or it can be to the left. So if you are given a diagram, consider the direction of these two, Fr and Ft. Those are very, very important. As we can see, Fr being vertical according to this diagram that we are having, according to this, being vertical, it means it was going to be used just like before, where we had to calculate the vertical reactions on calculation of those reactions. So that's why I'm saying you must consider these two. It's very, very important. According to our diagram here, Ft being horizontal as it was going to be used for what? Horizontal reactions. But like I said, it's going to depend with the setup or the way you are given your diagram. So you actually need to do a lot of questions so that you can get the idea of how do they actually ask those questions. All right, as we have this triangle, it's a right angle triangle, so you can use any application of a right angle triangle, which is working with these forces and also the angle that you are given. You can see that trigonometrical ratios can be used. So calculations can be done according to the angle of theta. And what is important is our Fr and our Ft. So Fr from Fn can be calculated. This is opposite according to our angle, and this is what hypotenuse. So this is the ratio of sine from our SOHCAHTOA concept. This is what? The ratio of sine, opposite over hypotenuse. So you're going to form the ratio of sine. So therefore, Fr is Fn, the sine of what? Of phi, which is the pressure angle. Ft is horizontal, and that is adjacent, this one. So adjacent and hypotenuse is from what? From cos. So it means Ft from Fn is going to be Fn cos of what? Cos of the pressure angle that you're given. That's a horizontal component. And this one being what? A vertical component. It's from the angles that you're given. We can play around with the ratio of a tan. Tan of the angle is what? Opposite over adjacent. So it's Fr over Ft. So meaning to say I can find Fr from Ft by simply make Fr the subject. So cross multiply. Fr is equal to Ft times what? Ft times the tan of what? The pressure angle. So this is now your mathematical skills, playing around with your mathematics, change of subject, whatever that you want. So you can even find the radial force from the tangential force. So it is just a matter of playing around with information that you are given. All right, so that is what we are going to also need in terms of your understanding. You can apply that one. So like I said, as of the reactions, nothing has changed in terms of our reactions. We are still going to consider those reactions just like before, to say Is it that we are to calculate the vertical or horizontal? But what you need to consider this time is that you are dealing with what? Bearings. You are dealing with the gears. We have got our gears, which is the gear system. So how are they going to affect our bearings now? We have a bearing here and another one here. How are we going to present our forces? Whenever you are to deal with the gear system, you use as it is. Use as it is. Given as it is. What am I trying to say? You are going to take your supports as usual. All right, these are our supports as usual. So when the two gears are given, let's say we are to consider vertical, horizontal, you check the presentation of those gears. All right, so this one, you have got something like this. All right, we have got our driver and the driven. So if we have the driver, in this case, below, we have it like this. The driver is what? Below, in our case. It means our FR, which is the radial force, is going to face up. Radial force can face up, can face down. Remember, we said this one, our radial force can be vertical, can be horizontal, depending with your diagram. So according to this view, the radial force from the driver, you push the what? The driven, you push like that. So your FR will be facing up. It will be facing up. With the direction that you are given, all right, with the direction that you are given of the movement, you now check to say, all right, how is the FT presented? Is FT to the left or is it to the right? You must also consider, but this will be for your what? For your FT. Meaning to say FT is in the horizontal. FR is the one that you consider for the vertical, facing up. So if the driver is below, let's say you are dealing with vertical reactions in our case, with vertical reactions. It means from the gear system, from the gears, we were going to use FR. Remember, there will be a pulley there will be a flywheel, but we are focused on the gears only. You are going to take FR facing up. This will be your FR. It is what? Facing up. So you take as it is. You do not oppose to say, all right, it is facing up, then I'm going to oppose it. If it is, no. Like what we had on the pulley system. So what you can do is to have all the information now together. You have all the information together. You combine all the information, then you play around with the diagram. So the gears, they do not have an effect to the bearings like what we saw before on the pulleys, to say from the tensions that we had, when the tensions are facing down, then it means the bearings will be experiencing an upward force. If the tensions are facing up, they'll be experiencing a downward force. No, it is not applied on the gear system. That one is not applied. on our gear system. So you simply have to maintain that. All you have to maintain. So if we check here, there is a summary of the gear system that we can use on our FR, especially on that radial force, because the radial force can be up or it can be down. So if you have a side view, all right, and the driver gear below, so you've got the driver below, your FR will be going up as a vertical reaction. So this is used for a vertical reaction. A side view. When you are given, let's say our driver is above, you can have that the driver gear is above. What is going to happen if the driver gear is above? It means our FR will be facing down. It pushes the driven, so it will be facing down. So this is the condition of the driver above this one. This one, driver below. So meaning to say your FR is affected by that condition of going up when the driver gear is above. It goes, the arrow is pointing down for FR. If you are given the driver gear to the left, it can be given to the left. What is happening when it is given to the left? This is what we have. The driver gear is to the left. So remember, the driver pushes what? The driven. So it will be pushed like that. So FR will be on the horizontal. FR will be on the horizontal and to the right. So here, guys, do not, this one is just a repetition to the right horizontal. This is one thing here. It will be to the right. So you'll be having your FR2 to the right. So the effect continues. If the driver, all right, here we want to consider, as we want to consider the driver, guys, so that we do not have confusion. We do not have confusion. If the driver is to the right, it will be like this. All right. This is the drive. So what is going to happen with our FR? It will be pushed. Pushes the driven. So it will go to the left. So whenever we have the driver gear to the right, it means our FR will be facing what? The left, which is this one. So this one's just repetition of what is not necessary. Repetition of what is not necessary. So you can consider that in conclusion to say the effect of our FR from the what? Driver and the driven can be determined. Remember, I said when you're dealing with the gear, take the forces as they are, as it is. All right, as it is. So that's what you're going to have in a summary. Driver below. So these will be effects of what? Effects of FR, our radial force. All right, so when the driver is below, we're going to have the driven on top. So what is going to happen? Remember, the driver drive the driven. So the driven, it pushes. So it always pushes to the driven. The arrow pushes to the driven. So it will be facing the driven. So the driven is on top. So means that the arrow is facing to the what? To the top. X what? Upwards. So our FR X upwards. Meaning to say, when it is acting upward, it is used in vertical reaction. Used in what? Vertical reactions. You must consider it on your vertical reactions. When our driver, all right, when this driver here is above, when it is above, this is our driver and what? The driven. So when it is above, remember, the driver always pushes to the what? To the driven, where it is downwards. So this will be the resultant of our FR. It will be facing down, X downwards, just like that. As it is, X downwards. So therefore, used in what? Vertical reaction. Remember, going up or going down, it's part of what? Vertical reaction. So it is used in what? Vertical reactions. Number 3, we can have the driver to the left. To the what? To the left. When it is to the left, it means the driven is going to be to the right. Always, guys. The driver to the driven. To the driven. Where is it? So it's going to be horizontal now, where it is given. The view, the way that you are looking into is going to be a horizontal view. So meaning to say, our FR in our case is going to be taken horizontally like this. It is what? To the right. This is horizontal. It acts to the right. So where is it used when it is acting to the right? Used in what? Horizontal reactions. So you use it when you're calculating what? Horizontal reactions. Used in horizontal reactions. Just like that. Then lastly, we can have the driver to the right. The driver to the what? To the right. When it is to the right, what do you think is going to happen? It's going to push this one to the left. Where it is, the driven is to the left. So you push that to the left. The driver to the driven. So meaning to say our FR at the end will be acting to the left. Acting to the left. So therefore it is used in horizontal what? In horizontal reactions. Whenever you are to calculate horizontal reactions and a gear system, the gears are there, you must consider how it is. FR always, FR pushes driven. It pushes, FR, it push from the driver, it pushes the driven, pushes the driven in the direction of what? The driven, just like that. So the opposite now of what we have here will be your FT. Your FT will be simply the opposite. To say this will be tangent now, FT. Which will depend now with the direction that you are given for that FT. So for FT, you must consider that FT the way it is given, as it is given. It will be your FT. It will be your FT. So meaning say, when FR acts downwards, when used for vertical reactions, FT is used for what? Horizontal. FT is used for horizontal at that moment. When our FR is used in horizontal reactions, at that moment, FT is used in the what? Is used in the vertical. Just like that. You combine this, you answer your questions. Combine and answer your questions from now. What you heard before on a pulley, and with this information of the gears, all right, where's the pulley? All right, let me just remove one or two so that we can see. Remember we dealt with the pulley, and I said as of the pulley, guys, you must consider the tensions. They affect our bearings in the opposite direction or opposite what? Opposite manner. Let's just stop. I did not remove that part. All right, so this was here for the pulley system. So now you must combine what you did here on the pulley system for vertical reactions, for horizontal reactions. Is it horizontal? Is it vertical? So meaning to say, when the question is asking about vertical reactions, you check, is there a flywheel? Because the possibilities that you are going to have for vertical, it will be a flywheel. You must check that one because it has weight. All right, facing down. You check for the pulley. The pulley system, does it have weight or the tensions T1 and T2? You check for that. Then the gears. So as of the gears, you also check to say what is in the vertical for our gears is what. All right, let's like I said, for the gears, use as it is. Let me remove this one also. And so if we check here, this is what we had for the what? For the gears. This is what we had here. The effects of what? Of FR. If FR is taken in vertical, let's say our FR is vertical, meaning to say on your vertical here, you are going to use FR. If FT is the one that is vertical, because at the moment where FR is vertical, FT will be horizontal. So let's say in our case here, FT is the one that is vertical. You use FT. So here for the gear system or for these gears, it can be FR or FT. Depending with the diagram, it can be FR or FT. You check for those two. Then how are they presented? Like I said, for the gears, take as it is. As it is, all right? You take as it is. The pulley system opposes, all right? The pulley system opposes bearings, our supports, like the way that you be given. But the gears, they don't have that effect because it can be just a gear system only. But the pulley now, it affects our bearings in the opposite way. Remember, I explained that condition to say you just have to swap to say, all right, it is going up. Then the gears, I mean, the bearings are experiencing a downward force. That's what I'm trying to say here. The flywheel, as it is, again, this one, it is just as it is. As it is, you just take your information as it is. The weight facing down does not to say. So when the weight is facing down, so the bearings are going to be experiencing an opposite force or what you just normally as it is. So for you to understand, you must do revisions now, questions. So make sure that you become part of the membership so that you do not miss any of the classes that we are going to be having as revisions, because like I said now, most of you will be in confusion to say, what exactly am I trying to say? So it means it needs you to follow up the questions now. Use this information. You answer any question, anyone for the line shafts that he has got what? That he has got the bearings and I mean the calculation of the reactions of the bearings. You can answer anyone. You have to make sure you do questions, all right? So adding to that information, because of time, I want you to add this as an individual, these formulas to the gears, all right? So as we deal with the gears, there is what we refer to as the gear ratio, all right, which is being taken from TS over TM. So these are the torques that we are given, the torque for the shaft and the torque of what? Of the motor. So that's the idea. So this is the shaft torque in Newton meters. Then this is what? The motor torque in what? Newton meters. So take note also for the motor to say, remember the principle of operation that we had before. The motor pushes, or it is, I mean, it not to push, but it actually supplies our line shaft. So when you have the shaft calculations and the motor is given, the information can be taken from the motor because it is the one that is supplying what? The shaft. All right. Power being taken as T1 minus T2 times the velocity. All right. You can calculate your power from the tensions. Remember, previously, when we were calculating power transmission, we use the formula power is equal to 2 pi nt over 60. Still, it is the same, but we are saying velocity can be used, which is velocity in meters per second from what? From pi dn over 60, the diameter, and we also have the speed. So we can use that. So these are formulas that can be used. You can use this one. You can use this one depending with the information that you are given there. The velocity, this is just to N4, guys, all right? Then the tangential force. This formula is very, very important for the tangential force. Mostly, they will give you information where this formula is to be used. So to use this formula, you are to calculate the tangential force. You must use the torque and the pitch center diameters for the same part. If it is the driver, it must be also the driver here. All right. If it is driven, this must be driven. So this is the idea. These two must what? Must be from the same. All right. Is it the pinion or is it the driven? These two must be from the same part. All right. So do not have a mistake on this one. That's why when you're given information where you are to calculate tangential force, they will give you the torque for that gear and the pitch center diameter for, I mean, the pitch center distance for that particular gear again. So it is something that you must be very careful with in your calculations. We also have the radial force. I referred to these formulas before, the radial force. So your FR can be calculated from FT that you calculated here, the tangential force times the tan of phi, in that case, the angle, that is your pressure angle. The radial force, all right, so we can have, this is the normal force, all right. This is a repetition of something. We've got the normal force. We've got the radial force. This is supposed to be FR, not FN here. FR, which is equal to FT. The radial force, this is supposed to be tan, not sec. FT sec, this is just something that was not supposed to be here. They just made a mistake when they were trying to reprint this one. All right, very sorry for that. So this one, it is just a repetition of something that is not. So these are the two that you just need here. The radial force and the normal force can also be determined. And these formulas, they are there from your formula sheet. You have this one. It is, you think, your formula number 9. This is your formula number 10. This is your formula number 11 from the formula sheet. You have these formulas, remember? So meaning to say, you can use it, take it direct from the formula sheet. So we are going to have questions where we are to apply the formulas and also to apply what we had on the moments application of moments, calculating those reactions, vertical or horizontal. So it needs time. You need also time as an individual to work on those basics so that we won't be having all this explanation if the basics are there. All right. So anyways, guys, this is what you have. And just add your theory part from your N4. Remember, you had N4. So just add also the theory as before. This can help also to understand what exactly you are working with. Why are we doing some of the other calculations with those basics that you had before? And do not forget, this is now a combination of everything from the first class. So make sure that you follow the playlist from the first video up to the end, and question papers also, because there will be just some other adjustments when you are dealing or working with the question papers or any other question, adjustments to be done. So you need to understand what exactly is happening. So that's it, guys. Till we meet again.